Hi, Dr. Revis here with Watch Me Work It. Identifying isoelectronic species. Simple math process versus periodic table counting. So watch me work it. First, a couple of principles. Isoelectronic compares a charged ion with a neutral element on the periodic table. In other words, you will have a charged ion, either plus or minus, and you are looking for its electronic match on the periodic table as a neutral element. Next, it identifies which element has the same number of electrons as a charged ion. These two bullets are saying the same thing. So basically you want to know which element has the same electronic count, or at least electron count, as the charged ion. Okay, a couple of tips. Math, if you're doing the math, plus means subtract electrons. And the math, minus means add electrons. The counting tip, if it's positive, you count spaces left, and you'll learn what that means. Minus means you count spaces right. Keep in mind that each box on the periodic table represents electron count. Okay? So, what element is isoelectronic with some charged species? So let's play with some. All right, let's start with, let's do n minus 3. And here's how we do it. First, we know we're looking at n minus 3. So I go to the periodic table and I find n. When I find n, I write down its atomic number, which is the count for the neutral electrons. So I have 7 neutral electrons. Since I'm using math, minus means add electrons. So I'd say add 3 electrons. I get 10. Then I go to the periodic table. I find 10. And I say that neon is isoelectronic. Excuse me. Nitrogen minus 3 is isoelectronic with neon. Okay? Get it? So this is basically nitrogen 7 with neon 10. Now, if I were to do that by counting on the periodic table, what I would do is I would go to the periodic table and I would find nitrogen. So here's nitrogen, and it's a minus 3. So that means counting is negative. I count right, 1, 2, 3 spaces, and I get neon. Let's do another one. Let's do gallium plus 3. So if I have gallium plus 3, I find gallium on the periodic table. There's gallium. I write 31. Since it's a plus charge, plus means I subtract electrons. So that's minus 3 and minus 3. Electrons here gives me 8, gives me 28. So I go to the periodic table and I find 28, and 28 corresponds here. Therefore, gallium plus 3 is isoelectronic with nickel. So gallium, which 31, isoelectronic with nickel, which is atomic number 28. If I want to do this by the counting method, then I would find gallium. Since it's plus 3, the counting method says count left. So I count 1, 2, 3, and I get my answer. Okay. Now, what if it was gallium with a minus 3 then? Let's just do this on the same sheet here. So we have gallium with a minus 3. By the math, I first go find gallium, and it's 31. Math says it's a negative charge, so math says negative, add, so that's plus 3 electrons. And that means I would have 34. Then I would go to the periodic table, find 34, and selenium means gallium. It's isoelectronic with selenium. Gallium, 31, atomic number 31 protons, is synonymous with selenium with 34 protons. That is, gallium minus 3 is isoelectronic with selenium, atomic number 34. And we can count and do that also. Start with gallium, 1, 2, 3 counts to the right, and we get our answer. Okay, so let's try some more. Silicon plus 4. We go to silicon, we find it. 14 plus means subtract. We get 10. So that means 10. Go to the periodic table, I find 10. 10 then is neon. So it's isoelectronic with neon, which is atomic number 2, which has 2 protons, by the way. And silicon is 14, which has 14 protons. In this case, we have 10 electrons here and 10 electrons here for neon. Okay, if for some reason silicon was a, say, -2, then let me just do this one by the count then. Silicon here, I count 1, 2, and it's isoelectronic with sulfur, okay, which is atomic number 16, and this is atomic number 14, okay. And if I just did the math just to make sure, this would be 14, and since it's minus, we add +2, and I get 16. This is a 6, by the way, okay. So we can count it or we can do the math. Let's do a couple more here. Iron. By the way, at any point you can pause this video and see if you can get the same answers. I have iron +2. So what's its isoelectronic element? So iron, find iron on the periodic table at 26. So it's 26 plus, say, subtract. So I get 24 electrons. I look for 24 electrons, and it's chromium. So it's isoelectronic with chromium. Iron, atomic number 26, and atomic number for chromium is 24. Okay. And so we could count that, or we could do the math. If iron had a -4, let's say, this we could count it right away and see where it is. 1, 2, 3, 4. So my math had better match 4 there. So that's 4. That's zinc, atomic number 30, and this is atomic number. Iron is atomic number 26, or the A number, it's often called. So here, it's an interesting thing about iron. If it oxidizes to a +2, it stays as a transition in terms of the electron count. If it reduces as a -4, it also stays within the D group here. Excuse me, not oxidizes -4, reduces -4. So if it reduces to a -4 with a -4, we get still electron count in the D group. Do the math, you get 20. You get 26. Oops, yeah, 26 for iron, and so minus means add +4, and we get our 30, which matches zinc. Okay. Cobalt. Again, at any point, pause the video and see what you get. Cobalt +6. Isoelectronic, so we have cobalt 27 plus means subtract. So it'll be 21. 1, 2, 3, 4, 5, 6. Okay. You'll get the trend now. That's C, and you could do the rest of it on your own. But what if I had cobalt with a -6? Now in the case of the +6, it's still in the transition elements. The -6, let's just see what happens to it. So let's just 26 7 plus 6 takes you up to 3, be 33. And we can check our math by counting. 1, 2, 3, 4, 5, 6. Okay, so this goes up to, if it's reduced form, it goes up to arsenic 33. Arsenic, clean that up a little bit for you. Don't want to. So arsenic, so here we have cobalt, which is 27, and it goes to arsenic with a 33 atomic number. Okay, and now its electronic nature is more like the metalloid series here than it is like a transition. Okay, well, a few more here. Let's say, what if I had, okay, else here, there you go. So we have scandium here for this one. So scandium is right here. That's atomic number 21. So that's 21. And let's say that's going to be a -4. I want to show you this. Let me show you how your counting works too. So that's 24, 21 plus, let's see, it's minus. Therefore, we say plus here. So that gives us 25. 1, 2, 3, 4. So there we go. Manganese. So again, minus. We add the electrons. And so we get this looks more like Mn with a 25. But let's say if this was Sc with a +4. So +4, that's 21. So we have to lose electrons. And so here we're just going to count them back. 1, 2, 3, 4. Looks like 17. Yeah, that works out. 17. So that's going to be chlorine. Atomic number 17. Scandium here is atomic number 21. Okay? Now, most people have memorized that oxygen carries, for the most part, a -2. That's what it likes to be. Well, when oxygen is -2, that means we have reduced it 1, 2 boxes over. That means it looks like neon. So we go from oxygen 8 to a noble gas here of 10, which is why oxygen likes to reduce. It's attempting to look like the noble gas. So oxygen -2 has the isoelectronic signature of neon, has the same number of electron counts. So here I just counted them. You know how to do it. This is 8, 2 gives 10. That's what happens with oxygen -2. In a similar fashion, if we were to take magnesium, which most tend to remember has a +2. So +2 magnesium, we count over 1, 2 spaces for this. We also get neon, because we start with magnesium, which is 12. And we go here because it's added, so we subtract it, and we get 10, which also is what happened when we took oxygen -2, because this is 8. So we had 8, and we added 2, and we got 10. And so magnesium +2 and oxygen -2 are both isoelectronic with noble gas neon here on the periodic table. So that's how we work these problems when it comes to identifying isoelectronic species.